Section 12.1, determining formula mass and molar masses. The objective for this section is to be able to calculate formula mass. Alright, so let's talk about what that is. Formula mass of a compound is the sum of all the atomic masses that we have in a formula. So, just a quick review here. If we look at this periodic table, remember the atomic masses, those are those little numbers down below. So that's what we're looking at. So if we want to say the atomic mass of hydrogen, and usually we're going to go probably with 3 significant digits, so we're going to round it off to like 1.01, or if we're talking about oxygen, instead of 15.999, we'll say, hey, it's 16.0. So we will usually go about 3 significant digits. Usually works pretty well for most of our calculations. So let's say that we wanted to calculate the mass, the formula mass of water. So basically what we're talking about is taking all of those atomic masses and adding them together. So for this we've got, hydrogen, a hydrogen, and an oxygen. That's what we have. Or we have 2 hydrogens and 1 oxygen. Okay, so we're going to take 2 times the atomic mass of hydrogen, which we said was 1.01. And a lot of times that one even gets just changed into 1. It's usually easier. Plus 1 times the atomic mass of oxygen, which is 16. And so if we multiply those out and add them together, we would get 18.02. So that's the formula mass of water, 18.02. So the object here is you need to be able to, given a compound, look up the atomic masses, add them all up for a substance. Let's do another example. Okay, this one's a little more complicated. It's CaNO3 in parentheses 2. So you got to think about, well, what does all this mean? How many of each thing do I have? Well, I've got 1 calcium, but I've got 1 there, but I have it times 2. So I have 2 nitrogens, and I would have, I've got 3 oxygens times 2, or 6 oxygens. That's how I would figure out how many each of those has. And then look up your information on the periodic table. Okay, so if you look up calcium, you'll see it's 40.08, so we'll say, hey, 40.1 is probably good enough for us. And if you want to go farther, there's certainly nothing wrong with that. You can certainly put it in there. You just don't have to. Nitrogen, if you look at nitrogen, it's 14.007. And we'll just say 14.0, 2 times that, and oxygen is still our 16. So we would need to multiply out 40, or add 40.1 plus 2 times 14 plus 6 times 16. And that would equal 164.1. Now, when I do this on the calculator, I just add, if I have a scientific calculator, it'll do things algebraically. So I just say 40.1 plus 2 times 14 plus 6 times 16 equals, and it gives me 164.1. All right, your turn. I want you to stop the video, and I want you to calculate these out, and then I will give you the answers to these and see if you did them right. So right now, take and stop the video. Alright, so here's the answers, and on the first one you can see there's 2 potassiums, 39.1, sulfur, 32.1, 4 times oxygen, 16, total 174.3. Copper oxide, we've got 63.5 for copper, 16 for oxygen, 79.5. On this one, a little bigger molecule, we've got 3 magnesiums, 2 because there's 2 times whatever's in the parentheses. So 2 arsenics and 8 oxygens gives us 350.7. On the last one, you had to create the molecule from the words, so hopefully you got the right formula. If you didn't get the right formula, obviously you're not going to get the right answer on this, which is why those ideas of being able to do all this stuff, as we go through chemistry, we just keep adding more and more things in here. So you get the formula Ca3 in parentheses PO4 parentheses 2, so 3 calciums, 2 phosphates, 8 oxygens, 310.3. All right, let's just talk just a little bit about the difference between formula mass and molecular mass. Technically, ionic compounds don't make molecules, and so they would not have molecular masses. You could only talk about their formula masses. So it's just a distinction. It's a technicality on this. Molecular compounds, you could use either one. They will have a formula mass. They definitely have molecular mass. However, if you interchange them, and people do quite often, it doesn't really mean it's not a terrible thing. Just be aware that there is technically a difference. Formula mass should be, or ionic compounds, you should talk only about formula mass. Molecular compounds, you can talk about either one. And of course, to confuse it all, in the next section we're going to talk about molar mass, which is really the same thing. So these all kind of mean the same idea. In every single one of these, you're simply adding up all of the numbers off the periodic table. And that is the end.